Hi everyone, this is Malia and this is my runoff experiment. Our first step to our engineering process is the ask. So my question is, how does soil and land cover impact infiltration and runoff? My second step is the imagine. So I thought of different ways that I would be able to prevent runoff. I have silt fences, I have grass, I have retention ponds, buffer strip, compost blankets, stormwater debris nets. So for my third step, my plan, I ended up still going with the prototype. I felt it was the most relatable to myself since I am surrounded by farming at my school as well as in my backyard. I actually have a creek that is connected to a cow farm. So I wanted to actually see how effective grass is when making sure that we don't have runoff going into our waterways. Here's my experiment. On the left, you can see that I have my grass. In the middle, you can see I have the brush. And on the right, you can see I have just soil. So according to my experiment, I used the same amount of water in each one of them. The grass actually had almost no runoff whatsoever. The brush had a lot more than the grass, and the soil had even more than the brush. So from this, I can determine that the grass would reduce the runoff amount. As you can see, though, the different runoff that was coming through was about the same when it came to quality, but it's going to be absolutely better for me to have grass as my filtration than it would be the other two that were there. So for my create of my experiment, I did try to grow my own grass. I wasn't able to grow it in the amount of time that we had, so I ended up actually having to get grass out of my yard. I didn't choose where the creek was, though, because that would defeat the purpose of the whole entire experiment. For my improve, I have a couple of things I would do to improve it. The first thing is I would try to use actual rainwater. We didn't really have a lot of rain in the last week, so it's kind of difficult for me to be able to do that in my actual experiment. Another thing I would do is try to make sure that my opening and my bottles aren't as wide as they were. I was having problems where the water was going over top of the edges. My third thing I would do is I would try to grow actual grass. It would be very relatable, my plant life cycle that I do in 4th grade as well. And it would be able to kind of to show the relationship where the plant's actually growing, but then how we can use it later on. So for my standard for the PA and environment and ecology standard, I chose to use the watersheds and wetlands standard, and I chose this for a couple of reasons. So the first thing I chose is we actually stress watersheds a lot in 4th grade, and that's what I currently teach, and how to prevent runoff going into streams and creeks. I also, in 4th grade, my kids do a field trip where they go to a stream that's in our district, and they analyze the different types of animals that are in the stream and see exactly how healthy the stream is. And my last thing is that we actually did a demonstration this week about watersheds that I had somebody come in, and they were able to create the pollution effectively and be able to see what kind of pollution can happen in our area, in our environment, and see how it affects our actual waterway itself. So I felt like they were able to do a little bit more hands-on, and they were able to see how it actually is impacting our environment. So my connections among STEM practices, my science and engineering practices I had was asking questions, developing and using models, plan and carry out investigations, analyze and interpret data, construct explanations, engage in argument from evidence, obtain, evaluate, and communicate information. My technology practices was learn how to use technologies as they become available, recognize the roles that technology plays in the advancement of science and engineering, make informed decisions about technology given its relationship to society and the environment, and mathematics practices, making sense of problems and persevere in solving them, use appropriate tools strategically and attending to precision, construct viable arguments, and critique the reasoning of others. And that was my science experiment. Thank you.